Hey, what's up, sports fans? Mr. Noldy here again, showing you a calculus problem that I did previously. I actually took it down. I just wasn't happy with it. So, if you're wondering about how to calculate volumes of revolution, stay tuned. So today we're talking about calculus, specifically solids of revolution. So one question a lot of people may have is when do I use the shell method and when do I use the washer method? And the short answer is you use the method that works out best for the given situation. But sometimes we don't always have a choice. So I'm going to show you the same problem twice, once with shells and once with washers. So this is the problem in question. It says determine the volume of a solid of revolution obtained by rotating the region bounded by y equals x squared and y equals x and the x-axis about the line x equals 7. Okay, so I'm going to go ahead and sketch this and explain to you why I would use the shell method. So we would have a graph kind of like this. Let me color coordinate here. We've got y equals x squared. So that would be, kind of this half of a parabola. And then we have, let's see, y equals x. So that would be, a diagonal line right there. So the region that's bounded by those is going to get revolved around, the line x equals 7. So this is the x-axis. This is the y-axis. And let me label those curves. So y equals x is the yellow curve, and y equals x squared is the red curve. Now, because these are both defined in terms of x, I'm probably going to use the shell method. This would be my preference. So I'm going to build rectangles that are parallel to my line of revolution. So this point here, let's say we'll call it x. These would intersect at 1, 1, right? We know that from these two curves. So here's a 1. And we're starting down here at 0. So, and this point, of course, would be 0, 0. So if I'm going to do this, I have to figure out what would be the radius of my shell. This is sometimes the trickiest part. But from here to where I'm rotating, how big is this radius going to be? This is going to be the edge of my cylinder that I'm building. So how far is that going to be? Well, from the y-axis all the way to here is 7 units. So I'm only going to here, right, for each one of my rectangles. So this distance I would characterize, or I would call 7 minus x. Right? So I'm just taking the whole distance from here to here, and I'm subtracting x. So that's my radius. So let's go ahead and set this up, shall we? So the volume is going to be, do we like red? Let's go with the white. The volume is going to be 2 pi. 2 pi times the radius is the distance around the shells that I'm building, but I have to multiply it by the radius first. So we're going from 0 to 1. And the radius of the shell is going to be 7 minus x. And then the shell height, like how tall is this shell right here? That's my shell height. So that's going to be the top curve, x. Let me color coordinate here. X. Let me get my thing turned off. Minus x squared. So x squared is on the bottom. So remember, we always do top minus bottom. So that's why I wrote x minus x squared. So now we have something we can integrate. So let's go ahead, and I'm going to have to FOIL this business right here. So first times first, and then outers, and then inners, and then last times last. So let's go ahead and do that. So my volume, still going to have this 2 pi here, is the integral from 0 to 1 of, let's see, first time first, 7x. Outside, 7x squared. Inside, minus x squared. And last times last. Negative times negative, that's a positive x cubed. So notice everything is in terms of x, is dx here. So let's go ahead and here. I have some like terms to combine. So volume equals 2 pi, and then we'll integrate from 0 to 1 of, and I'll probably write my x cubed first, minus x, 8x squared, plus 7x. So there we go, with respect to x. So let's go ahead and integrate now. So I'm going to scooch this up a little bit because I keep hitting my pause button. 2 pi. Let's see, this becomes 1/4 x to the 4th minus x cubed. So this would be 8/3 x cubed plus 7/2 x squared. That's going to be now. And we're going from 0 to 1. So I like the 0 here because 0 minus 0 plus 0. So I don't even have to worry about that piece. So let's go ahead and substitute the 1 in place of all the x's. So easy enough. 2 pi would be 1/4 minus 8/3 plus 7/2. And we're not, this is like minus 0 out here. So I'm not even gonna bother writing that. So we need to go ahead and get a common denominator here. So we have 4, 3, 2, so that would be a 12. So let's see, I'd have 2 pi times 3/12 minus 30 times 4, 32/12 plus times 6, 42/12. So go ahead and add all those 12ths up. So I see 10, 42 minus 32 is 10, plus 3 is 13. So that would be 2 pi times 13/12. So 2 and 12 cancel. So we just have 13 pi over 6, right? Because 2 goes into 12 6 times. So that is the exact answer. The volume would be 13 pi 6, or probably would type it in a calculator. I got 6.8 for that. So quick recap. We left everything in terms of x. So because it was given in terms of x. And it's being revolved here, so we had to get the radius of the shell. This is the height of the shell, this white line here, and this is the thickness of each shell. So now we just do the calculus. So now, that is how I would do it if I were not told how to do it, just because these things were in terms of x. But what if you're asked to do it the other way? So let's look at that. Alright, so same problem here. Determine the volume of a solid of revolution obtained by rotating the region bounded by y equals x squared and y equals x and the x-axis. And we're still going to turn it around x equals 7, but they're telling us, use the washer method. So here's what we're going to do. We're going to sketch this out again, and I don't remember exactly which colors I used, but here is y equals 7 is way out here. I'm sorry, x equals 7. So this is the x-axis. This is the y-axis. And let's see, our curves were, I think I went red on the x squared. So that would be y equals x squared. But if I'm going to do washer method, let's draw them both in there first. And here is my line, y equals x. So again, the same curves, they both cross at the same place, 1, 1. So before we were going from 0 to 1 in the x direction, now we're going to have to be going from 0 to 1 in the y direction. But here's why I would have done it with shell method, is now I have to rewrite this and solve it for x. Well, this one's pretty easy. That just becomes, let's switch to yellow. That's just x equals y. And this one up here, this would become x equals the square root of y, because we'd have to take the square root on both sides, right? So let's write up a integral. So this would be the rectangles I'm building. So they're going to be revolved around this curve still, but now relative to this axis, my blue curve line is on top of, let me get my pointer, my blue curve is on top of this curve relative to where my axis of revolution is. So I'm going to have to do top minus bottom. So remember, for this, we had volume equals pi. It's not 2 pi r, it's pi r squared. And we're going to have a big R squared minus a little r squared, depending on your textbook, times how thick is each one of these things. And they're going this way, the thickness, so they are going to be in terms of dy. So dy. So this whole thing here. So the big one is going to be that's my blue one, because the blue one is the curve that's on top, again, relative to my axis of rotation. My little r is going to be the red piece, because that is on the bottom relative to my axis of rotation. So let's go ahead and make some substitutions. So volume is going to be pi times the integral. Again, we're going from 0 to 1, but we're doing it in the y direction. So let's see, big R would be just x equals y, so that's y. So I'm going to have my y. Then well, actually, let me rephrase that. How far are we rotating from? This r is how far away from here. So this is 7 all the way to here minus this distance. The blue distance is going to be my x equals y. So I actually do need a 7 minus y in here. And then that's our big R, so don't forget to square it, minus my little r. So little radius. So right now we're just taking a big area that's going to go all the way to here. But we need to subtract this area to just leave us with this area in here. Okay? So that would give me 7 minus, my thing's doing crazy things here, 7 minus the square root of y, and square that, and this whole thing is with respect to y. So this is how we would have to do this one if we were using, if your problem said on your final exam, use washer method, you're going to have to do some rearranging. So pi times the integral from 0 to 1. So I'm going to FOIL this out, so that becomes what, 49 minus 14 plus y squared. Make that look like a better plus. And then minus this one foiled. So that's 7 times 7 is 49. Outers plus inners is 14 again, but minus 14 radical y. Oh, and I forgot a y over here. That's a y. Let's see, and then last times last. That's radical y times radical y. Negative times negative. That's going to give us a positive. So the whole thing, dy. I guess technically I need some more symbols of inclusion here. So go ahead and simplify the integrand here. So I see something cool going on. 49 minus 49, those add off. Let's see, then I'm going to have a y squared. Then I'm going to have, let's see. Ooh, I have to be careful here. I have a negative 14y, and this is a positive y, but I have to distribute this negative. So it's negative 14 minus y is going to be negative 15y. And then last but not least, we have our plus, because minus times minus is plus 14 times the square root of y. And that is a positive. So in order to integrate, I probably should have written this term with a fractional exponent. So I'm going to go ahead and do that. You don't mind, right? Y to the 1/2 power. So now, I'm going to scooch so I don't turn myself off again. So now we're going to integrate. So I have pi times, let's see, 1/3 y cubed minus 15. That's going to be a y squared, so 15/2 y squared plus times 2 divided by 3, so 28 thirds y to the 3/2, because we have to increase that by 1. And this is getting evaluated from 0 to 1. Now, same as before, this 0 works out kind of nicely, because 0 minus 0 plus 0 doesn't have any effect on the problem. So we're just going to focus on the 1. So if I have a pi times 1/3 times 1 minus 15/2 times 1 plus 28 thirds times 1. So all I need to do is get me a common denominator here, which would be, let's see, 2 and 3 would be 6. So I have pi times 2/6 minus, so let's see, times 3 would be 45/6 plus, times 2 would be 56/6. So go ahead and add those three fractions together. So 56 minus 45 is 11/6 plus 2 is 13/6. So that's the same thing that we had in the last problem. So this equals pi times 13/6, which becomes, the exact answer is 13 pi over 6, and we evaluated it, or we approximated it to be 6.8. So there you go. That's two different ways to look at those problems. I prefer to do, this is my personal preference, I prefer to do things dx, especially because this was originally set up in terms of x, the problem. So this I had to turn around and make it into y's. So it's doable, but now I'm dealing with radicals and dy's. Not my favorite thing, but it might be your favorite thing. So compare that to the previous one that we did, that we just left it in terms of x because that's what it was to begin with. But the shape that you're revolving is still the same shape. It's still the same size. You're going to get the same solution either way. right? About 6.8 cubic units. All right, so I hope you got value out of that. Go ahead and hit the like button, please. I appreciate it so much. All right, so isn't that cool? You get the exact same volume whether you did the washer method or the shell method. So it just depends on the problem. If I'm not told what to do, I do what works out easiest for me. But like we saw with the second part there, sometimes you'll be required to go ahead and change that because the instructions might say to go ahead and use the washer method. So hopefully you got some value out of that. If so, go ahead and hit the like button and maybe even consider subscribing. Catch you the next time.